So from here, what is the value of a given that a does not equal to 0? Solution. Now, from here, we have so let us raise the power of this by 1, the power of this by 1. So if we raise the power of both sides by 1, we're going to have so we have this power to be 1, this power to be 1. Then let us note that we can have 1 to be equals 2 over 2. So meaning we can replace this one here as 2 over 2. So we're going to have this as now. From here, when you have, let us recall, when you also have a to the power of m, so we can have this to be equals this. So from here, we are going to have this as 5 to the power of a over 2 to the power of 2 minus 4 to the power of a over 2 to the power of 2 equals 269. Now, since we have this power 2, let's define what we have here as m to be equals 5 to the power of a over 2, then n to be equals 4 to the power of a over 2. Now, we have this to be m squared minus n squared equals 369. So, let us recall from difference of 2 squared. When you have a squared minus b squared equals as a minus b times a plus b. So now, when you apply it here, so we are going to have this as m plus n times m minus n equals 369. So from here, we are going to have this from here, m plus n in parentheses greater than m minus n. So, and again, 369, we can have it as 41 times 9. So this implies we cannot have it to be m plus n in parentheses times m minus n in parentheses will be equals 41 times 9. And the reason why we don't want to consider 9 times 41 is because this 9 is lesser than what? 41. So from here now, we have to equate then m plus n will be equals 41. Let's name this as question 1. Then m minus n will be equals 9. Let's name this as question 2. Now, by solving this equation 1 and 2 simultaneously, let's add first. So when we have it to be 2m will be equals 41 plus 9. 2m will be equals 50. Divide 2 by 2 we have our m, then our n will be equals 25 as this. Then also from this problem again, let us also subtract. So if we subtract from here, we are going to have n minus m will cancelled. Then we have n minus into minus n, then will be equals 41 minus 9. We have n plus n, 41 minus 9. This will give us 32. Then we have 2n equals 32. So divide through by 2. This will cancel out. Then we have n to be equals 32 divided by this will be 16. We also have n to be equals 16. Then from here too, if our n equals 16, now well, so if we recall from here now, meaning we are going to have 5 to the power of a over 2 that equals m, and our m equals, then we have 5 to the power of a over 2. So let us now have m in base 5 as 5 to the power of 2. So if we have this to be equals this, so there's need for us to equate the power since the base are the same. So if we equate that, so we're going to have from here a over 2 will be equals 2. Then 2 times 2. And so therefore, we're going to have our a to be equals 4. So we have our a to be equals 4. Again, likewise, when you also have, let's from here, you know, we have a to be equals 4. Then we have to recall as well. If we recall, again that we have 4 to the power of a over 2 to be equals n, and our n equals 16. So our n equals 16. So from here, we are going to have 4 to the power of a over 2 equals 4 to the power of 2. And so from here, we have to equate the power since the base are the same. So this we are going to have a over 2 equals 2. And so from here, we have a equals 2 times 2. So we have our a to be equals 4. So we have a to be equals 4 from here too. And if we want to check, so to check, we have to recall from the problem given to us that we have 5 to the power of a minus 4 to the power of a equals 369. Then when a equals 4, what we are going to have will be 5 to the power of 4 minus 4 to the power of 4. Then it's going to give us 369. So now from here we have 5 to the power of 4. This will be 625 minus 4 to the power of 4 will give us 256. Then it's going to give us 369. Now we have 625 minus 256. Now we take 1 from here, here remains 5. This will be 12, take 1 will be 11, this will be 15. 15 minus 6, this will give us 9. 11 minus 5, this will give us 6. There is 5 minus 2 will give us 3. We have 369, which equivalent to what we have here as 369. So since the left equals to the right hand side, the left hand side are the same, and this tells us that A equals 4 is perfectly correct. Now, it's perfectly correct. So from here, we have this as the first Olympiad problem that we're going to look into this video. So, and the problem is we are given 5 to the power of A minus 4 to the power of A equals 369, and we got the value of A to be equals 4. So we got the value of A to be equals 4. Now, let's see the second problem that we're going to look into. We have another problem to be problem 2. We are given A to the power of 5 minus 1 to be equals 0. Now, we are given this as the second problem. So, if you know it, comment in the comment section below. Comment below what is the value of A. What is the value of A? So from here, we can solve this easily. So we have this to be A to the power of 5 minus A to the power of 4 plus A to the power of 4. Minus A to the power of 4 plus A to the power of 4 will be 0. Then minus A to the power of 3 plus A to the power of 3 will also be 0. Then minus A to the power of 2 plus A to the power of 2. Then from here to minus A plus A. You see all this will be 0, 0, 0, 0. It will not affect the first problem given to us. Then minus 1 equals 0. Now, let's regroup this expression as this. Then we pick them like this. So if you have them as follow like this, we're going to have this as A to the power of 5 minus A to the power of 4. Then plus this will be A to the power of 4 minus A to the power of 3. Then plus A to the power of 3 minus A squared. Then from here to, we have A squared minus A. Then we have A minus 1 equals 0. Now, what is common between this and this is A to the power of 4. Factor it out. Here will be A to the power of 4. This divided by this will be A minus 1. What is common between this is A to the power of 3. Factor this will be A minus 1. What is common between this is A to the power of 2. Factor it out, here will be A minus 1. A is common, factor it out here will be a minus 1, then plus a minus 1. Everything equals 0. Now, from here, a minus 1, a minus 1, a minus 1, a minus 1, a minus 1 is common. So when we factor it out, from here, what we're going to have will be a minus 1 in parentheses. Then here will be a to the power of 4 plus a to the power of 3 plus a squared plus a plus 1 equals 0. Now, from here we have this. From zero product rule, is either we have a minus 1 equals 0, or we have a to the power of 4, a to the power of 3, a squared plus a plus 1 equals 0. So from here, what we are going to have will now be we have this. You can see from here, we are given a minus 1 equals 0, and we have a to be equals 1. Now, the second solution is a to the power of 4 plus a to the power of 3, a squared plus a plus 1 equals 0. So from here, we are expected to have 5 possible solutions for this problem. So now from here, we have to divide through by a squared. So from here, dividing through by a squared, we have a to the power of 4, a to the power of 3, a squared plus a plus 1 divided by a squared. 0 divided by a squared here will be 0. Now, so from here we have this a squared divided by this will be a squared. This divided by this will be a. This will be 1. This will be 1 over a. This will be 1 over a squared equals 0. Let's group this and this together. We have a squared plus 1 over a squared. Then plus a plus 1 over a. Then plus 1 equals 0. Having them in parentheses, so we're going to have a squared plus 1 over a squared. A plus 1 over a plus 1 equals 0. So from here, let m to be equals a plus 1 over a. If our m equals this, let's square both sides. Here will be m squared, a plus 1 over a squared. So we have m squared equals, this will be a squared, 2 times a times 1 over a plus 1 over a squared. So we have m squared we have this to be a squared. This cancels out this. We have plus 2 plus 1 over a squared. Now, from here we have m squared minus 2 equals a squared plus 1 over a squared. So if you substitute this in the above, and we substitute this here, so what we're going to have finally will be m squared minus 2 plus m plus 1 equals 0. We have m squared plus m minus 1 equals 0. Now, so we have from here m to be equals minus 1, positive or negative, with 5 over 2. Solving this problem, this is what we're going to have. Now, let us now substitute. Let's substitute. Recall that we have a plus 1 over a to be equals m. And our m equals 1, minus 1, positive or negative, root 5 over 2. Meaning we can now define this as a plus 1 over a equals minus 1 plus root 5 over 2. A plus 1 over a to be minus 1 minus root 5 over 2. So we have this. Finally, the LCM will be a squared plus 1 minus 1 plus root 5 over 2. When you cross multiply, we have it to be 2a squared plus 2 equals minus 1 plus root 5 multiplied by a. Now, from here, we have 2a squared then plus we have 1 minus root 5 a plus 2 equals 0. Now, when you solve this quadratically, we are going to have, for this, we are going to have a to be 1 we have, when you solve this quadratically, we're going to have this to be root 5 minus 1, positive or negative, root of 10 plus 2 multiplied by root 5i over 4. You know, when you had this is two solution with another solution again. With case this one, we're going to have a to be minus into root 5 minus 1, positive or negative, 10 plus 2 multiplied by root 5i over 4. This two solution makes to be 4 plus a equals 1. Taking this one to be making this one to be 5 solutions. So meaning that this problem, we have 5 possible solutions. Now, that's how. So let us also solve now. That's for this problem. So now in this video we've covered 2 problems. The first problem is we solved 5 to the power of a minus 4 to the power of a, that will have it to be 369. And for this problem, we got the value of a to be equals 4. Then for the second problem, we have a to the power of 5 minus 1 to be equals 0. And we got 5 solutions. We have first a to be equals 1. Then we have another a to be equals, we have it to be root 5 minus 1 in parentheses, positive or negative, square root of 10 plus 2 multiplied by root 5 multiplied by I over 4. Then we also have another a to be minus into root 5 minus 1 positive or negative, root of 10 plus 2 multiplied by root 5 I over 4. This is 2, 2, 4, make it to be 5 plus this one. Now, the next, we're going to look into this problem again, problem 3, which is two x to the power of 3 equals 8. Now, in this problem, how many solutions are you expected to have for this? You are expected to have 3 possible solutions because of the power 3. Now, from here we have 2x to the power of 3 2x to the power of 3 equals 8. Now, from here we have to express this in base 2. So here with 2x to the power of 3. Now, let's have this as 2x to the power of 3 minus 2 to the power of 3 equals 0. So let's also recall from when we have a to the power of 3 minus b to the power of 3. We call this difference of 2 cubed. And this also equals a minus b so this always equals this. And so when we apply it here, what we are going to have will be 2x minus 2, because obviously our a equals 2x, our b equals 2. Now, times 2x squared plus 2 times 2x plus 2 squared equals 0. So from here we have 2x minus 2. This will be 4x squared. This will be 4x. Now, from 0 product rule, so we have this to be 2x minus 2 equals 0. If this equals 0, definitely multiplied by here will be 0. We have 4x squared plus 4x plus 4 equals 0. So from here we have 2x equals 2. Divide through by 2, we have x equals 1. And from here to, we have this to be 4x, let's factor 4, x squared plus x plus 1 equals 0. Divide through by 4. So from here we have x squared plus x plus 1 equals 0. And so from here we have minus 1 positive or negative root of 1 minus 4 over 2 minus 1 positive or negative root of 3I over 2. So we also have the solution to this as well to be this. So if you are new here and find it interesting, don't forget to share, like, comment, and subscribe for more math tutorial videos. Bye bye. Then don't forget to subscribe, comment, like, share,